Hello, my friends of Qatari Labs. My name is Paul Montoya. Please welcome to this webinar. And this webinar is the modeling of hydrological units from raster data with Aquifer App and Gempy. Okay, so for this webinar, what you need to download the data from here, and the password is Qatari Labs. I will do it right now. Qatari Labs. Okay, and this will you will have this file that you download. Okay, and then here on downloads, control C. Okay, you do control C and then you paste it on documents. Why? Because it's important that everybody will have the same path. That this is related to Anaconda. So you extract here. So you extract here with the WinRAR. Well, this is RAR, you have to use WinRAR. Okay, so if you have it like this in your document folder, please type 1. If you have it like this, please type 1. Through the chat. Okay, if you have it like this, please type 1 through the chat. Hello. Okay, if you have downloaded and then you have placed it here on your documents, please type 1. Okay, great. So let's see. Please type 2 if you have Anaconda installed in your computer. Please type 2 if you have Anaconda installed in your computer. Okay, who else? Okay, great. Okay, great. So everybody just go to Anaconda Prom. Okay. CD documents, and that is why we need the document folder. CD webinar or hydrological unit from raster data, and here we launch Jupyter Lab. Okay, everybody, here we launch Jupyter Lab. So while you are launching Jupyter Lab, okay, let's have a look on the data set that we are going to do. Okay, so here we have the doc, and the doc we are going to work with some raster data, and that raster data came from this data set that is the hydrological framework of the uppermost principal aquifer system in the Williston and Powers River structures, Williston and Powder River structural basins in the border between the USA and Canada. Okay, let's see. Well, the report is there. There was this effort to understand. Okay, we are going to work with a small part of that, but the geological setup is this one. Okay, so here we have glacial till. In the data set we don't have. Okay, so the data set that we are going to work doesn't have glacial till. Okay, but for other parts there are some upper layer of glacial till. Then it comes the upper Fort Union aquifer, the middle Fort Union, the lower Fort Union, the upper creek, the lower creek, and the falls hills. Okay, and on the at the bottom there is the basal confining units. Okay, if you are here with me, please type 3. If you are here with me, please type 3. Oops. Who else is here? Okay, I need more people, two more. Okay, so here we have, well, 7 layers, okay, and if you go here to the raster, okay, you are going to see the top of each layer, okay, you are going to see the top of each layer. However, okay, who is here with me, please type 3, okay. If you have any problem, this is my WhatsApp number. Okay, who else? You can send me a screenshot of your problem and then maybe I can help you on the spot. Okay, so for when you are working with Gempy, you are not working with the top, okay, you are working with the bottom. Okay, so for example, let's see, the top of the upper aquifer, the top of the upper aquifer layer of the upper fault union is the surface. The top of the middle fault union is the bottom of the upper fault union. The top of the lower fault union is actually the top of the lower fault union is the middle fault union. Okay, if you have understood this, please type 4. If you have understood this, please type 4. Okay, and the top of the upper Hell Creek is actually the lower of lower fault union. Okay. Yes, great. So this is the data set. So actually the top of the basal confining unit is actually the bottom of the Fox Hill. Okay, so this is how it works. Okay, so we have launched Jupyter Lab. Okay, so we have launched Jupyter Lab, and here I'm going to copy this, Control C, and then I'm going to paste it here. Where is the provided PDF? The PDF is here on the in the content in here in doc. That's the PDF. Okay, yeah, shred. Okay, great that you're following and great that you are interacting. Okay, so let's see. Let's go to scripts. Okay, so here we have some data set for the data processing. That is the most important part here. Okay, so that is how we are going to work in order to create the files for the Gempy model. Yes, okay, so just one question, aquifer.hatarilabs.com. Yeah, do you have your account of Hatari Labs? Okay, yeah, if you don't have your account for Hatari Labs, you have to register yourself. If you haven't registered, do it yourself. If you have any problem, I can help you right now. Okay, so but if you have your account, please type 5. If you have your account in aquifer.hatarilabs, please type 5. If you don't have your account, please register. I can. If you have any problem with the confirmation email, I can help you. Okay, great. If you are registering, please type registering, or if you already have an account, please type 5. Okay, registering. Okay, great. You are, yeah. Okay, so let's see, let's create a new notebook that is going to be called webinar. Okay, let's have a new notebook that is going to work. Okay, great. So let's see it. Give me 1 second. Okay. First, start by importing the required packages like import OS, import rasterio, okay, import GemGS as GG, import numpy as NP, import pandas as PD, import geopandas as GPD, import matplotlib.pyplot as plt, from shapely.geometry import line string. Okay, so these are the packages. Okay, and it can be possible, okay, it can be possible that you don't have some of these packages. For example, here I don't have rasterio, so I have to install rasterio, pip install rasterio, pip install rasterio. Okay, and this will install rasterio, and from installing rasterio it will upload all those packages. Okay, for yours can for example, here I don't have GenGS, so I have to build rasterio GenGS. Okay, maybe geopandas as well. Fiona, I don't have Fiona, I have to install Fiona. Okay, if the package is already there, it will say, okay, the package is there, so no installing will be needed. Okay, so if you were able to input, for example, here, yep. So here, those were all the packages that I needed, but maybe you have to install your pandas or something like that. Okay, so tell me the truth. If you are here with me, please type 6. If you have any problem with your account, I have given you my WhatsApp number. Come on, this is a live session, so no, you don't have to live with any doubts here. Okay. The account registration link is this. Okay. You just have, in order to register, you go to signing, login. Okay, and then you go to Hatari Labs, continue, and then you register, and then you put your name and so on, and then you confirm. You get a confirmation email and so on. Okay, if you are here with me, please type 6. Great, Vinicius. Great. Okay, something that I will tell you about this webinar. This webinar will be posted in our patreon.com/Qatari Labs. That is a paid subscription that with just $5 you are helping us, and exactly you are supporting my daily coffee, because actually I use that money to just buy coffee. Okay, however, it is important that you actually support. Okay, so the video will be after the webinar here. Okay, and maybe in 1 month it will be released as a as a tutorial. Okay, so just considering in supporting our research, we have a lot of topics to discuss, and well, and then if you support us, we can do even more greater things. Okay, who else is here with me? Please type 6. Okay, so let's see. Let's talk about the area of interest. Okay, so we have a polygon that is the area. Okay, we need a polygon. You can create a polygon. You can do it with QGIS, with any other. So in this case, we have GPD dot read file. Okay, and this is from shapefile. Okay, it's from shapefile, and it's called AOI.shapefile. Okay, great. So we have bounds. Okay, we need the bounds, and they also AOI dot total bounds to list. Okay, great. And AOI extend is equal to, okay, so we need this is bounds 0, bounds 2, bounds 3. AOI extend. Okay, great. So this is the minimum x, minimum y, maximum y of the area of interest. If you are here with me, please type 3. 7. If you are here with me, please type 3, 7. If you have any problem, let me know. I'm here to. Who else is here with me? Seven. If anybody has any problem, just send the. Okay, who else? Who else is here with me? Just Vinicius? If anybody has some error in their scripting, GMG's error. Could you send me just send, okay. Could you send me the screenshot of the error to my WhatsApp if you use that application? Okay, so let's continue because we have a lot of. Okay, send me the screenshot of the error and then I can help you. Okay, so, well, what we are going, okay, the dimension of this is we have 144. I think that the units is feet. Okay, so we have 144,000 feet in the x dimension and 86,000 feet in the y dimension. Okay, so let's see. Now we are going to do a raster list, and the raster list is a list comprehension x for x in os.list here. Okay, in the folder raster. Okay, this is a list comprehension in Python. If x ends with, okay, tiff. Okay, so if this ends with tiff, So we have the raster list. So those are all the raster files in the in here, okay, and omits all of these XML files that are actually not of our interest. Okay, if you are here with me, please type 8. Okay, and my friend Yashari, you have to put pip install Fiona. Okay, just run this cell before importing your uh, before importing your okay, right, just run this before importing and let me know. Okay, so that's it. Okay, so we need, okay, what we need is okay, since we are going to work, okay, so the rasters are for the top and then we are going to work with the bottom. I will give you through the chat, okay, or well, you are going to see it here, okay, a dictionary. Okay, you just copy paste this on a cell, okay, that actually makes the conversion from the top of the layer to the bottom of the uppermost layer. Okay, so of the upper layer. So for example, the top of Fox Hill is the bottom of the lower Hill Creek. The top of Upper Fort Union is actually the surface. Okay, so we need that because we need to convert. Okay, we need to relate not to the top of the layer but the bottom of the other layer. Okay, if you are following me through here, please type 1. If you have any questions, let me know. If you are here with me, please type 1. If you have any questions, let me know. Okay, great, Vinicius. Who else? Okay. So now what we are going to do, okay, so we have the different rasters, okay, but we want, okay, in order to interpolate, okay, we are going to sample the raster, okay, we are going to extract the elevation of the raster at certain points, okay. You can work with many points, okay, because when you insert to GeoGS, you are going to insert the XY set. Okay, you are not going to insert a raster, you are going to send, so we need to sample that. Okay, how we are going to sample? We are going to sample through a loop. Point list is equal to an empty list. Okay, for raster in raster list is equal to if layer dict if layer dict of raster is different to model top, because actually model top won't be inserted here. Model top layer name is equal to layer dict of the raster. Okay, so the raster, so this will be the layer name, not this one, this. Okay, and the raster obj is equal to rasterio.open, okay, of raster plus raster. Okay, partial point list is equal to empty close, set values and xy values is equal, and then we use GeoGS raster dot sample randomly raster is equal to raster obj and is equal to 20. Okay, great. So we sample, this is a function from Gempy for x, y, z. Okay, in zip, well, zip is a function of Python that joins two lists as an iterator. X, y values 0, x, y values 1, it values. Okay, partial point list dot append. Okay, x, y, z 0, x, y, z 1, y, z 2, layer name. Point list, okay, and then we add it to the partial point. Okay, and so point list is equal to, okay, so let's see the first two items that we have created. And then we have, for example, the X, the Y, and Z, and the bot, and this will be then this is the bottom of, for example, the Fox Hills, okay? The Fox Hills layer. Okay, so this is okay, the list is actually much larger, okay, but here we have a great sense, okay, and then we have, for every layer, we have 20 points. You can have 120 points, okay, that is possible, but actually, on the calculation, you are going to spend more resources, and it will be more time consuming as well. So this is actually and it's up to you. I mean, you can recreate this with more points if you want. If you are here with me, please type 2. If you are here with me, please type 2. Okay, who else is here with me? Just Vinicius? Mhm. Okay, okay, well. Mhm. Okay, okay, who else? Okay, yes, continue. So we have the surface df is equal to pd data frame of point list. Okay, so we are going to create a point list. Okay, and the columns will be x, y, z, and formation. Formation. Okay, surface df head. Okay, so we create a data frame. Okay, and then we surface df to CSV Okay, and then we store that on CSV, and this will be model surface dot CSV. Okay. Okay, so we have created here on CSV, we have created the model surface. Okay, great. So now let's work with the orientation. Okay, orientation df list is equal to list. Okay, for raster, in raster list, if layer d raster is different to model top, because model top won't be used here. Model top is equal to model top, so layer name is similar to layer dict of raster. Raster obj is equal to rasterio dot open. Well, this is similar to what we had it before, raster plus raster. Okay, so here we have layer df surface df. Okay, surface df formation. Okay, so we are going to filter the surface layer name. And why we need to filter that? Okay, so we have a list of the point x is equal to layer df x to list point y is equal to layer df y to list. Okay, so random points is equal to np dot random dot choice np range of length of point x. Okay, so size is equal to 3 and replace is equal to false. Why I have, okay, why I have done this? Okay, I have done this. Why? Because when you work with a lot of, for the orientation, when you work a lot of with a lot of orientations, the code actually will get really slow. Okay, and then if you have a slow code, actually will take more time, and so that is why of the 20 values we only get 3 values. Okay, so we get 3 values of these 20 values. So this will be the random points. Okay, and then we, from those 3 values, we sample the orientation. okay, for just the 3 points. So this is for point Y. Point Y. Okay, and formation. Okay, and so here is orientation df list dot append of orientation df. Okay, I have a problem here that says sample orientations. Okay, so these are okay, it has already sampled for each layer, it has already sampled just 3 points, not the whole set of 10 points of 20 points, but just 3 points. Yes, okay, great. So finally, what we need to do is model orientation model orientation tail. Okay, so we create a data frame. Okay, and this is the data frame of the orientations. Okay, and then we save that as a CSV. Okay, because with the surface and the orientation is what we need to get into Gempy. Okay, so this is the okay, so with that we have created the orientations. Okay, so we okay. Yep, okay, so the model orientation is just created. Okay, so yes, okay, so if you were not here, you can do this part. Okay, let's go to Aquifer. Okay, now we are going to use Gempy. How we are going to use Gempy? So we go to sign in. We go to Hatari Labs account. You need to use your Saul Montoya age. Okay, your username and your account. Everybody can do that. Okay, great. And then here we create a new project, and the new project will be webinar. Okay, if you are here with me, please type 2. Okay, so if you haven't gone through the Python stuff, you can still do that because the sample files are there in the data provided. If you are here with me, please type 2. If you are here with me, please type 2. Who else? Okay, great. Okay, so we just create them, and then we go to edit. Okay. Yeah, so here we have plots and freq. Okay, so you can do the Piper plot here in Aquifer App. You can run freq here in Aquifer App, and then we can run Gempy. So we start and we create. Okay, so what we have to create is a pod because we are going to virtualize our session. And why do we need to virtualize? Because some steps of this calculation actually take a lot of resources, so it has to be distributed. So we go to the view, and then we stop. Okay, the x, the y, the mean, this comes from your data. Okay, and if you wondering, the x, the y, the mean, and the z are, where are those, please? Okay. No, sorry, not this one. This. Okay, the x mean, it comes from the AOI, so this will be the x mean. This will be the y mean, the x max. This is the y mean. This is the y max. That's great. And then the set mean, it really comes from your data. Okay, but we are going to work with 200, and the maximum data will be 206,000. Okay, and the set resolution will be, let me check because I forgot. The how many cells will be 144. You define that by the way. You have to do your calculations to see, and if you make and then 48 layers. Okay, if you make a more dense cell number of cells, okay, you will create a more finer model, but it will take more time. Okay, so that is really up to you. And we are not going to use for them data, and then we have one fold, group, fold, and strat. We only going to have one. If you are here with me, please type 3. If you are here with me, please type 3. No, as I told you, the video will be available for right now for the Patreon followers. Okay, and in 1 month it will be available as a tutorial. Okay, who else is here with me? Evelyn, Yasari. Okay, just a question. Do you feel that the Python level of this webinar is actually high? Let me know. Hey, Vinicius. Yeah, yeah. Thank you. Yes, I think that most people also watch the video here. But if you are watching the video, make your questions because this is also possible. Okay, I have for example, there is a friend of yours that has kind of, there is a problem here with the, for example, let's see, no, what happens if you have my files, okay? you have your path is something like that. And there is a space here. Okay, Python is not good at looking at the spaces on the path. Okay, and this is something that you have to try to omit. Okay, so if you are going to, if your username will be half a space, please try to work in another folder that is not related to username. Okay, because it's really hard to locate the files when you are using some spaces here. Okay, this is something that is that will be my advice. Okay, so here we go to select. Now we back. Okay. And there is, yeah, I will restart, and because there is a trick here on the set version. Okay, and okay, I will restart again. So this will be my first. Okay, then there is also this. Okay, and this is the y min. This is the y max. Okay, so this will be 144, 86, and this will be 40. Okay, and this is the problem. Okay, if you do tab from 86, actually it will jump to the set. But there is sometimes that, for example, that you cannot not touch here. So and this is because of the zoom. So you have just to do, whether you do a zoom out, so now it's available, or you place yourself in this Y, and then you just with tab you jump to the set, that the set is 48. Okay, this is the trick, and this is just it. Okay, Vinicius, you have raised your hand. Yeah, okay. You have the raster. You have the raster, and then you have many raster for every layer. Okay, you sample points. You define the amount of points, and then you sample the orientations. Okay, and from that you create the point of surface and the point of orientation. Okay, great. Okay, so we do select, and then we go to orientation. Orientation, we go to the webinar, to the CSV, and then we are going to see the file that we have created. Upload. Okay, if you are here with me, please type 4. Okay, and then once you have uploaded, you have to do next. Okay, and type 4, please. If you are here with me, please type 4. If you have any problem, let me know. Okay, well, now we get the surface. This will be the surface. Okay, and these are the surfaces, all the set of surface, and then we do compile. We need to compile. Okay, everybody do the compilation. Okay, and the order is the upper for union, the middle for union, the lower for union, the upper Hell Creek, the lower Hell Creek, and then the Fox Hills. Okay, this is the, and this is 1, 2, 3, 4, 5, and 6. Okay, and then just type upload. If you are here with me, please type 4. If you are here with me, please type 4, type upload, and type 4. If you are following, as well type 4. Okay. Great. So now let's do upload. Okay, and then you will have the points, the orientation, you will have the structural frame, and then you will have some plots. Okay, so this is a cross section in the x direction and the y direction. The orientation are the arrows. Okay, the orientations are the arrows, and as well on the z axis as well. Okay, so okay, that's great. So these are the orientations. Okay, but this is too heavy for the pod to run. Okay, this is really heavy for the pod to run. So we are going to download the project. Okay, my recommendation is that your download folder will be empty. Okay, and now we download the project. Okay, now you download the project and then you extract here. You extract this. Okay, so here what you are going to find is with the okay. First, let's go to the webinar. And this Gempy app will be the backup because you are going to have a new one that is the one that you have created. Backup. Okay, so this is the backup. And then here you have the MNT, and then you have this folder that is a new one, Control C. Okay, and then you are going to paste it here, Control V. So this is the new folder of Gempy app. If you are following through here, please type 5. If you are following me through here, please type 5. If you are following me through here, please type 5. If you are following, okay, it doesn't matter that you are actually, okay, if you are getting the idea of the process, please type 5 in the chat. Great. So we need to run this on local. Okay, how will you run this to local? You go to the Gempy app, you go to model data, and the total script, you just edit it. Okay, we need to edit. So I am going to use Notepad. And how you did that? Okay, so file name will be Gempy comma. Yeah, so because we are going to create a Gempy log. Okay, so the orientations will be this path, and the surface points will be this path. Okay, you don't have to do nothing here, and the image there will be this path, and the VTK there will be this path as well, and that's it. Okay, so these are all the changes: VTK there, image there. Okay, and then we have changed the paths here to be relative. Okay, and that's it. That is mostly what we have done. Okay, so we save that. Okay, and then we are going to run. Okay, we can run that from Jupyter, but actually I can run this with calling another time Anaconda prompt. Yeah. CD documents, CD webinar, CD Gempy, CDP2 model data. I type there, and then I will find the Gempy total script. That is a file that I have modified. So I say Python Gempy total script. Okay, so that is how I run this locally. Enter, and I say I don't have the package pip install Gempy. So actually Gempy was not installed in my computer. Maybe you have another ones, another. Okay. Okay, so we do clear. CLS is in Windows, and now we do pip Python Gempy total script. Okay, and I don't have Gempy viewer, so I will install pip install Gempy viewer. I need that as well. Please don't. It's CLS. So I run the Gempy total script and then I wait. Okay, as Vinicio has told, okay, so it will be nice that you get this on this webinar, okay, and then later on you can recreate this on your computer, okay, because uh, it's really important that you follow the it's a new procedure, and actually this is just pure software, open source software. Okay, so because for you actually I don't know this procedure, because when I teach QAS and R in the other software, I knew at that time, I knew both software, but now I don't do know any other software. So this is the way that I know to do geological modeling. So, and my success, it will be that even that you found this in Python, and then you find that you start to know the procedure, and then you start to see that you can do your geological models here. Okay, do you have any questions? Do you have any questions? Mhm. Where the different scenarios that are, which are the different scenarios, sorry? Yeah, yeah. Yeah, yeah, there is a question that if, for example, what happens when you have intrusion, or what happens when you have fold in what you have, you are working with volcanic rocks and sedimentary rocks. So there are some options. Even in Aquifer App, there are some options for that. The what is important is that I have made a lot of tutorials on Gempy app, okay, but my intention is to cover all of these steps, okay, so actually that you see and apply case that is similar to you, but it's done in Python. So that will be kind of my strategy to make people work with that, to work with Gempy app. Mhm. So okay, yeah. So if you have any idea, you have my WhatsApp number. You say, okay, I want to model this, and we can develop a webinar as well. Okay, so and about the video, considering supporting us in patreon.labs, because the video will be right there. Okay, and then with that, you can make me drink a coffee, because this is exactly what I consume every day. Okay. It actually takes time, and I won't deny it. So, and then we have, okay, I will take advantage to work about the two platforms that we have. Here we have the shop.catrilabs.com, where you can find diplomas, courses, and there are, for example, there is Python for water sources, Modflow, FlowPy, and then we have courses as well. And then we also have we have the e-learning platform, okay, that is more a legacy because here we have more older courses, okay, and then you know that by also buying our courses, you are supporting our research as well, okay. So let's see again, and again. Okay, it's still computing. And then we have to keep waiting. Okay, you can tell me from where you're connecting, which is your Python level, and so far, which is the opinion of this webinar. Okay, so how many people are connected to these 6 people? 6 with me, 4 people are connected. So please introduce a little bit of yourself. Okay. Yeah, PES is so abstract. Yeah. Well, it's I mean, it has tool for everything, but in the end, it became a bunch of 68 executables. Yeah. Okay. Okay. Okay, great. Before the introduction of the other people, well, we have finished, okay? So when you have finished, you have the gempy.log. So the gempy.log that says, okay, it has taken 353 seconds to run the interpolation, okay, just to sample, okay, just to measure how which will be the performance, okay, and okay, so there is and it has created, okay, the code has created, here on the webinar, has created on the Gempy app in P3 has created the lithology.btr, okay, and the surface, okay, and it has created in P4 some total sections. We can see those sections. These are partial previews, are actually not the best visualization. We are going to work with better visualizations, but it's okay. So this is the X without refine. This is the Y. Okay, and the set direction of the interpolated model that we have created. Okay, great. So that is great at a certain depth. Okay, but now let's work a bit with the, okay, I can close this. Okay, now let's work a bit with the surf with the scripts because there is a geometry work. Okay, so we can work with this geometry work, and this one opens, it creates from the raster, it creates a BTK. Okay, a BTK is a type of 3D format. You don't have, okay, you just have to run this. So it will create a BTK in the kernel, restart and clear all sets. Okay, first we import and then we create the model top.btk. Okay, model top.btk. So if so it has created the model top.btk. Okay, and then we are going to clip it. Okay, yeah, BTK can be viewed, but okay, why we are going to clip it? Because okay, we have, okay, right now the geological box is a box, okay, but you have surface, so you have interpolated lithology values in places that are on the air, so we have to clip it to the model top. So this is what it's doing. Okay, great. And if you see, there are some functions that I have created that do that. Okay, and now, okay, now with the clipped surface, I can go to paraview. Okay, and then I can work with the clipped, with the clip grid.btk. That is the one that it has created. Okay, so this is paraview. So I open that, documents, webinar, btk. There is the clip grid.btk. I do okay. So that is okay. I'm going to do a threshold, and the threshold will be by in and out. So the in will be the 0 value, and the out will be the other part. Okay, so this is the threshold of the in and out. Okay, great. But I will do a vertical exaggeration because that is twofold. Okay, so and this is the interpreted. Okay, and as well I can select another comes step. Okay, so and these are the interpolated hydrogeological values. Okay, those they are the interpolated hydrogeological units. Okay, and as well these units, and as well you have the surface as well. You have the surface. You have the surface here in the Gempy app P3, the surface. You have the surface of all the, okay, you have the surface of all the files. Okay, and as well here you have 10. I'm going to take out this. So these are the different surface. Okay, so these are the different surface. Okay, great. So these are the different surface, and this is the threshold. Okay, so I'm going to put some opacity here, 0.3. Okay, just to show you the different surface and the different units. Okay, so that will be the interpolation of the geometry that will be stored as a BTK, and this is done with Aquifer App and Gempy. Okay, Vinicius, I think that you were following this. Do you have any final comment on the webinar? Okay, thank you for your opinion. Okay, what is also my interesting is, for example, to do spatial interpolations with neural networks, because, for example, you have concentrations, and they will be kind of the same. Okay, so you just in Aquifer App, you will have another point where you gave your X, Y, Z, and it will create a plume or whatever. Okay, I'm thinking a lot, or lithology interpolations as well. Okay, so any other comment from the people here from Yasire, Evelyn, and Semap? Okay. There is a question about the VTK. Okay, this is not GIS. These are spatial files. Okay, that because these are 3D files. Okay, so they're okay. Even that they are geographical represented. Okay, you have to work with them in Paraview. Okay, there are some tutorials on, for example, let's say check files to VTK. Files to VTK. Okay, there are some tutorials where you can put your own data to VTK. Okay, so yes, so you can work with your own data in VTK, and then you can compare the locations, drilling, and so on. Okay. Okay, but it's, I mean, as you say, it's work that you follow the steps, that you know the steps, and then you are going to see that all the steps actually are 80% the same, even that you model a small thing or like a big scale. Okay. Any other comment? Okay, great. And for the other people here, okay, I will stop the recording. And just from which part of India are you?